Hello, my name is Ramasu, and welcome to my presentation on question 4 from the 2008 BGCSE Double Science Award Paper 2. The question says figure 4.1 shows the potential difference, or PD, across the ends of a conductor is related to the current passing through the conductor. We have voltage or potential difference on the y-axis and current on the x-axis. Part A says what is the relationship between potential difference and current? Well, from the graph we can see that as current increases, potential difference also increases. So the relationship is proportional. So we say that current is directly proportional. Proportional to potential difference, right? Because as the potential difference increases, the current also increases. And part B says which law defines this relationship? This is Ohm's law. This is Ohm's law, the one that says voltage is equal to current times resistance, right? And part C says use the graph to find the resistance of the conductor. So from Ohm's law, which is this one here, V is equal to I times R. R is the resistance, and it is found by the equation R is equal to V over I, right? So you can use your graph to find out the value of resistance by saying that change in voltage divided by change in current. So if we look at the voltage here, the voltage changes from 0 to 10, right? So then we have a 10 minus 0, because it starts at 0 and then it goes to 10. Then we also have a change in current, which goes from 0 to 5. So we have 5 minus 0. This is the same thing as 10 over 5. So then our answer becomes 2. So 2 ohms. So then our resistance is equal to 2 ohms. Right? And then part B says on figure 4.1, draw a graph for a conductor of the same length and material but with twice the cross-sectional area. Okay, so my resistance is directly proportional to length of a conductor. So the longer your conductor is, the more resistance the conductor will have, and resistance is inversely proportional to area, or rather to cross-sectional area. Resistance is inversely proportional to cross-sectional area, right? So if you have a piece of wire like this, right? So from one end to the other end, this is the length, right? And this area here, is the cross-sectional area. This is the cross-sectional area. So the longer your wire is, the higher the resistance. and the bigger your cross-sectional area, the smaller your resistance. Right? So if you have a large cross-sectional area, then your resistance will be low. Okay, so now they tell us that a conductor of the same length and material, but which has twice the cross-sectional area, right? So we can use the equation that R is equal to the resistivity times length over the cross-sectional area, right? So because they tell us that the cross-sectional area is now okay. So we use this equation here to find the resistance of this new conductor. Okay, so they tell us that the two conductors have the same length, right? So let's make L the subject of the formula here. We have R times A over resistivity equals L. So because L1 is equal to L2, L1 is the first conductor and L2 is this new conductor here. So then because L is equal to a resistance times area over resistivity, we say that R1 times area 1 is equal to resistivity. This is equal to R2, which is the resistance of the new conductor, times and they tell us that the new conductor has twice the cross-sectional area of the first conductor, right? So the area of this new conductor here, R2, is like twice that of A1 here. So we have 2 times A1 over rho. Now what happens is that this rho and this rho are the same, so they cancel out, and we end up with R1 A1 is equal to 2 times R2 A1. And once again, because these A1s are the same, they cancel out, so then we end up with R1 is equal to 2 R2. Now we know that R1 is equal to 2 ohms, right? So we can write this as 2 ohms is equal to 2 R2. So then to find the value of R2, we divide through by 2. So then R2 is equal to 1 ohm. So then we draw the a line with a gradient of 1. Right, we then draw a line with a gradient of 1. A line with a gradient of 1. So that's the line with a gradient of 1. Okay, so that's our line. Also, one thing I forgot to mention, which is very, very, very important, is that this is a potential difference versus time graph. So the gradient of this graph, gradient is equal to resistance. So this is why we did all this working here, so we could find the resistance of this new conductor, because the resistance is equal to the gradient. So if we know the gradient of the conductor, or if we know the resistance, which is the same thing as the gradient for the new conductor, then we can draw the graph for the conductor here. Okay, so because the gradient is 1, it means that the values of x are going to be equal to the values of y. So we have x being 2 here, and then our x also is current. So we have current being 2, and so our potential difference is 2. We have current being 4 amperes. Our voltage is also 4 volts. We have current being 6 amperes and voltage is 6 amperes. Okay, so that's the end of the video. My name is Ramasu. Thank you for watching. You can find me on Facebook at Ramasu, or you can follow my page BGCSE tutorial videos if you need more help or if you want more videos. Thank you for watching and see you on the next video.